Okay, we are back for the second notes video of Unit 3, and we are talking about domain and range. I went over a little bit of it on the last video, but didn't go into it in great detail, okay? And we're going to go into it in a lot of detail here. So, domain, okay? When you do the domain and your graph is connected, okay? We went over domain and range when it was a scatter plot and you list all of the x's and all the y's. I generally put them in order from least to greatest because that makes the most sense. So when you actually have a graph that's connected for the domain, you're going to scan your pencil left to right for the domain and identify the x values in which you are touching the graph. For the range, scan your pencil, okay, low, write that a little bit better, low to high, low and high. And I would prefer to, it's not I didn't make these notes, but if it was me, I would prefer to say from low to high and identify the y values in which you're touching the graph. So let's go to number 1, domain. So domain is from left to right. So you have to start on the far left of your graph. So right here, anywhere where you see an arrow, that's going to be infinity or negative infinity. Okay, so this right here, we've got an arrow going to the left. That means it's going left forever. So that's going to be negative infinity. If I can draw a better infinity sign. All right. So now, going the other direction, the far right side of our graph, okay, is also an arrow, which is going to be positive infinity. Like so. Because it's going to the right forever. Now, range, low to high. We actually have a true low point on this graph right here. And that would be at -2. Every single point is going to be a bracket for your range or domain unless you actually see an open circle or unless obviously it's an infinity. So here we're going to have bracket, and where is the lowest point on the graph? It's at -2 where I made that little line right there. Now, remember, range is from low to high. So where's the highest point of your graph? Well, these arrows signify the highest point of your graph. They're going up forever, so that would be positive infinity. All right, number 2. This one's a little bit easier. Okay, you have a true far left point and a true far right point. All right, so you're going to have brackets, obviously, because you don't have open circles. So what is the far left point? Count to the left. Well, it goes to -3. What's the far right point? Well, count to the right. It goes 3. So domain is from -3, and I'm going to erase this right here. So the domain is from -3 to +3. Range, low point to high point. So here's your low point right here. And again, that's a bracket. So that would be, again, -3. And then here's your high point. So that would be +3. There's your domain and range for that circle. Number 3. So on this right here, this one's pretty simple. Okay, for the domain, your graph has an arrow. So anytime you have an arrow, you know that you're dealing with infinities. That goes to the left forever, which would be negative infinity. This arrow goes right forever, so that would be positive infinity. Range. So you're still dealing with arrows. This arrow goes up forever. This arrow goes down forever. So the low point would be negative infinity because this arrow goes down forever. High point would be positive infinity because this arrow goes up forever. So both domain and range are from negative infinity to positive infinity. Number 4. Okay, so domain. This arrow right here is going left. I understand it's going down, but it's also going left forever. So that would be negative infinity. This arrow right here is going down, but it's going right forever. So that would be positive infinity. All right, range. Range is from low to high. Remember, domain is from left to right. Range is from low to high. So for the range, these arrows right here are going down forever. So your low point would be negative infinity. Now, we actually do have a true high point, meaning the graph stops right here, this line that I just drew. So that would be my high point. I just need to count up to it. So 1, 2, 3, 4, 5. So 5 with a bracket would be my high point. So my range is from negative infinity to 5. Number 5, very similar to the circle that we did a little bit earlier. You have a true left point, which would be negative 1. You have a true right point, so that we got to count over to that. So 1, 2, 3, 4, 5. So your domain is from negative 1 to 5. Now we do the range. Range is low point. So count down to that. So 1 to negative 3. And then we have a true high point. So count up to that. 1, 2, 3. So there's my domain and range. From negative 1 to 5 is my domain. Negative 3 to 3 is my range. Number 6. Again, anytime you have arrows on the end of your graph, you're going to have infinities somewhere. You just need to make sure you pay attention to see where they go. So, starting domain. This arrow is going down, but it's also going left forever. So that would be negative infinity. This arrow is going up, but it's also going to the right forever. So, positive infinity. And then, as I just stated, okay, this first arrow is going down forever, so low point is negative infinity. And then this arrow is going up forever, so that would be a high point of positive infinity. Number 7. This one's a little tricky. So, domain, left to right. This arrow is going left forever. So, negative infinity. This arrow, I understand it's pointed up, but it's also going right forever. So, positive infinity. It's not pointing straight up. Okay? It's pointing slightly to the right, which means it's going forever in that direction. Range. We actually do have a true low point at 4 different spots for our range. All right? So count down to that. So that would be negative 1, negative 2, negative 3 would be our low point of our graph. Now, most people would look at number 7 and they would say, here's my high point. Well, that's actually incorrect. These arrows go up forever, passing those 3 points that I just made, so your high point is actually positive infinity. Number 8. So domain. We actually have a true far left point, which would be -1. And then I think it's pretty obvious these arrows are both pointing to the right, going forever, so you're going to infinity. All right. Range, low to high. This one's pretty simple. That arrow is going down forever, so negative infinity. That arrow is going up forever, so positive infinity. And that would be your domain and range. Number 9. So we've got a straight up and down line right here. So domain, this is our graph right here. Okay, actually I'm not going to circle, I'm just going to highlight it. This is our graph right here. Okay, so it's not going left or right at all in any direction. So anytime that you have a straight up and down vertical line, you have to know for the domain, where is the vertical line at? Well, if you count over 1, 2, the vertical line is at 2. So because this graph is not going, because this graph is not going left or right in either direction, the domain would be x equals 2. I mean, this vertical line is at 2 to the right. The range is really simple. Low point, obviously that's going down forever, so negative infinity. That's going up forever, positive infinity. And then the same is going to go for this next one. It's just opposite for number 10. Okay? So this is the line we're dealing with now. So for the domain, it's really simple. That goes left forever, so negative infinity. That goes right forever, so positive infinity. The range, this horizontal line is not going up or down. So range is always y. So it's going to be a y equals, and then you just got to count down to it. 1, 2, 3, 4. So y equals -4 because it's below the x-axis. So anytime you have a vertical line, your domain is going to be an x equals. Anytime you have a horizontal line, your range is going to be a y equals. Number 11. So we actually have true stopping points on this one. So the far left point for the domain would be right here. And if you count to the left, that's -2, and it's a closed circle. The far right point is right here at that open circle. So if we count to the right, 1, 2, 3, 4, 5, this is actually going to be a parenthesis because you actually see an open circle. Range, low point to high point. So this would be the low point of our graph, and it's an open circle, so I'm going to go ahead and put a parenthesis. Now we just have to count down to it, so -1, -2. This would be the high point of our graph, right here, and that would be at +1, and that would be a bracket, because it's not an open circle there. Number 12. Domain, far left point to far right point. So this would be our far left point. So if we count to the left, -1, -2, -3, -4. And then this would be our far right point. So if we count from the center, you always count from the center. So 1, 2, 3, 4, 5 to the right. So the domain would be -4 to 5. The range, low point to high point. So the lowest point on the graph is right here. So we just need to count down to it. So -1, -2, -3. So -3. The high point of the graph is right here. So we just count up to it from the center. 1, 2, 3, 4, 5. And then we have our domain and range. (13). So domain, far left point to far right point. So this right here, this arrow means that this graph is going left forever. So -infinity. Now, it does have a far stopping point on the right here, that I just drew my pencil through. So that point right there is where it stops on the right. If you count over to it, that's 2. And it's an open circle, so parenthesis. Range, low point to high point. Well, these same 2 points actually are for the range. So the low point, this arrow right here that I drew, that I have circled, I'm going to circle it again, that is going down forever. So -infinity. For the range, this is your high point right here. So that is actually on the x-axis. So the range, the high point would be 0 because it's on the x-axis. Number 14, last one of these. So domain, far left point would be right here. So if we count to the left, that would be -2. Far right point is actually this arrow right here, which is going up, but it's also going right forever. So that would be +infinity. Range, this is also your low point, but you have to count down to it. So we would go -1, -2, -3, -4. All right? And then your high point is actually going to be the arrow going up forever. So +infinity. So hopefully you've got a pretty good understanding now of how to do the domain and range of graphs. Functions. Functions are actually pretty simple, okay? A function is, and I'm going to blow this up and make this kind of big, is a special relationship between x and y values and then your x values, which is your input, cannot repeat. Meaning you cannot have any duplicate x's, okay? So no duplicate x's would make it a function, and then obviously the exact opposite. Duplicate x's or more would make it not a function. So for example, if I gave you 4 points, Just going to make them up off the top of my head. Look at all the x's. So 1, 3, 8, -3. All of them are different function. Really simple. Then if I gave you another example, but very similar. So if I said 1, 4, 1, 7, 8, 5, -3, 4. Clearly you saw the change that I made. These two ones right here are duplicate x's. That would make it not a function. All right, so let's look at these. So all we got to do is look at the x's. Really simple. 5, 3, 2, 0, -1. All of them are different, so function. Look at the x's. -2, 0, 2, 3, 2. We have duplicate 2's, so that is not a function. All right, come over to number 3. So -4, -3, -2, 1, -3. We have duplicate -3's, so that would be not a function. 1, 2, 3, 4, 5. Clearly, right straight in order, no duplicates. That would be a function. And instead of writing them out, you can label function as F and not a function as NAF for not a function. So number 5, same thing, just look at all your x's. So 3, -1, 0, 2, 3. You've got 2 3's, not a function. All right? So look at your x's on 6. -4, -2, 1, 2, 5. All of them are different, so function. Number 7, -5, -3, 0, 1, 2. All of them are different, so function. Number 8, 1, 4, -7, 4, -1. You've got two I'm sorry, wrong one. You've got 2 -4's. So that would be not a function because you have a duplicate. Cannot have duplicate x's. Number 9, -8, -4, 0, 4, 8. So all of the x's are different, so that's a function. Number 10, 1, 2, 3, 4, 5. Clearly that one, there are no duplicates. Number 11, if you look at the x's, there's only one arrow going out from each one, so that's a function. Whereas number 12, you can see that this right here, you have 2 arrows going out from the -1. That means that you have 2 -1's. That would be not a function. You cannot have duplicate x's. And then if you look at 13, you see that there's 1 arrow going out from each of the x's. That would be a function. All right, vertical line test, last thing on this video, okay? Vertical line test, so I'm gonna write down what it is, okay? And kind of an example, it is when you drag a vertical line, or like your pencil, okay? Your pencil, you can turn it straight up and down. That could be your vertical line. So drag a vertical line across the graph. If it hits the graph at more than 1 point, it is not a function. Meaning at any point in time, if any part of your graph is straight up and down, it's not a function. Or if you can hit 2 points. So for example, if I drew something that looks like this, I could drag my pencil or even draw straight lines across here. And at no point, and obviously that arrow does not count, okay? So I'll kind of go off of that. But you can clearly see that it's only hitting at 1 point on this graph. Now if I drew this, and then I just drew one line. So this vertical line test shows that you're hitting the graph at this point and at this point. You cannot have 2 points in the same vertical line. So this one would be a function, this one would not be a function, because this one is actually hitting the graph at 2 points, meaning your graph is got more than one x value in the same vertical line. All right, so let's look at this right here. Hopefully everybody spotted this right here. You see that straight up and down vertical line? 2 dots in the same vertical line. They want you to know, is it a function or not? That is definitely not a function. You cannot have 2 dots in the same vertical line. That's the whole point of the vertical line test. Number 15. So if you run through each dot to check and see if there's only 1 dot, you'll see that each one only has 1 dot in each vertical line. 16. Obviously, there is no point on number 16 where you see any vertical line in this graph, meaning any straight up and down. You also cannot see the graph hitting at 2 different points if you drug your pencil across. So that would be a function. Meaning I could draw these vertical lines and it's only going to hit this graph once. All right. 17. Well, this one's obvious. It doesn't matter. I can go several different places, but I'll pick these 2 right here. Do you see how that vertical line, it hits twice? And then, I mean, there's several other points that you can do on this one. I mean, there's this one right here, and then there's this one right here. So this one is clearly not a function, not even close. Same thing with a circle. We just did a circle a little bit ago. You have many, almost pretty much throughout the whole entire graph, you have 2 points in the same vertical line, so clearly not a function. 19. If you look at 19, you cannot see any part of this graph that's straight up and down, or that would have 2 points on the same vertical line. So this one is a function. Number 20. Well, that is the vertical line test. So obviously not a function. Meaning your whole entire graph is going straight up and down forever in both directions. So every single point is on that vertical line. Clearly not a function. You can't even have 2, much less infinity. All right. 21. If you look at 21, at no point is there a line going straight up and down, and at no point you will have 2 dots in the same vertical line. This one is a function. Hopefully that helps everybody out with function, not a function. And that would be the conclusion of this video.